Hey everybody, video note 6.3, last one of the semester, and we have one big objective here, calculate the percent composition, mixtures and compounds, alright? So make sure you look at the book, section 10.3, read it, love it, know it, okay? We know other people love moles in chemistry, so here's what we gotta do. We gotta figure out what is percent. Percent is always the part over the total. How many people in our class are naughty and didn't get presents and won't get presents from Santa? Well, let's see. Out of the 24 people in our class, Lisa and Jerry aren't going to get presents. So let's see what percent that is. That's the part 2 divided by 24. What do we get? 0.083, and then we multiply by 100 to get percent. So it's 8.3%. Lisa and Jerry will not get presents. Percent is always part over total, part over total. Okay, so why is percent important in chemistry? Because it helps us identify how much of an element is in a compound or a mixture, okay? So how can we get percent? We can use the formula of the compound. Percentage of carbon dioxide. Okay, this is by mass. We're always doing these by mass. So we want the percent of carbon, we want the part over the total. So we go to the periodic table, we get 12.01 grams for carbon, divided by the total, 44.01 grams for CO2. How did I get that? I got the 12.01 for carbon, 16.00 for oxygen times 2, gives us 44.01. Then you multiply by 100 to make it a percent, and you find out that carbon dioxide has 27.29% carbon. So we can figure out oxygen in two ways. We can subtract it from 100, or we can say, well, in carbon dioxide, there's 32 grams of oxygen, because there's 2 oxygen, for every 44.01 grams of carbon dioxide total, part over total, times 100 gives us 72.71% carbon dioxide, oxygen in carbon dioxide. Hey, guess what? Every time you have carbon dioxide, this is the percent by mass of each element. Okay. How about iron and iron 2 sulfide? Well, first we need the formula. Iron's Fe. This means plus 2. Sulfur's S. Periodic table tells us it's -2. The formula for iron 2 sulfide is FeS. Then you can go to the periodic table. Okay. Percent iron is 55.85 grams of iron over the total 87.92 grams of FeS. Total, part over total times 100 gives us 63.52% iron in iron 2 sulfide. We can figure out percent of sulfur by subtracting from 100, or we could take 32.07 grams of sulfur for every 87.92 grams of iron 2 sulfide times 100. 100 gives us 36.48% of sulfur in iron 2 sulfide. Okay, so there's the percent composition by mass of each element. Hey, let's practice again. Find the percent of each element in water. Water, H2O. H2O. Okay. So, percent hydrogen. Well, there's 2 hydrogens, so 2.02 grams. Hey, where did I get the grams? From the periodic table. Divided by the total mass. We have 16 and 1.01 times 2. 18.02 grams for water, H2O, times 100. Okay, so it's 2.02 divided by 18.02 is 11.21% hydrogen by mass in water. What about oxygen? Well, you have 16.00 grams of O, part over 18.02 grams total for water. Total times 100 gives us 16 divided by 18.02, 88.79% oxygen in water by mass. All right, so percent is part over total. We can use it for elements using the mass from the periodic table. Okay, but we can also do it from an experiment. All right, pretend we have 95 grams of a sample of a substance, and when it decomposes, we get 40.6 grams of carbon, 54 grams of oxygen. Well, percent of carbon is the part of carbon, 40.6 grams carbon, over the total, which is 95.0 grams total. Notice I'm not writing a formula down there because I don't know the formula, I just know the total mass. All right, we find out that's 42.74% carbon in this substance, and then part for oxygen is 54.4 grams of O over the 95.0 gram total. All right, times 100 gives us 57.26 grams of oxygen. Hey, let's look at this, all right? The first example for calculating percent with carbon and oxygen, the answers were 27.29 and 72.71. 27.29% and 72.71% oxygen. The example we just did, it was 42.74% carbon and 57.26% oxygen. Could these two compounds be the same compound of carbon and oxygen? The answer for that is heck no, because if a compound is exactly the same, then no matter what sample you have, you should get the same percentages of the elements. Okay. The first compound we had, we knew it was carbon dioxide because we used a formula. The second compound we had is actually carbon monoxide, okay, which is not so good for you. All right, so make sure that you realize that carbon monoxide and carbon dioxide are different. So percent composition can help us analyze the substances we have. Hey, what if you had this data? What is the percent of each element in the compound? Well, here's calcium oxide. So this is the part, percent calcium is the part, 30.02 grams of calcium over the total, 42.28 grams of calcium oxide, which I know the chemical formula of, and I find out that you get 71.00% of calcium in that compound. So you might be saying, how can I figure out the mass of oxygen, percent of oxygen, when I don't know grams of O? Well, you do know grams of O, because 42.28 grams total minus the 30.02 grams of oxygen tells you that there's 12.26 grams of oxygen. I said oxygen. This was calcium. Woohoo, calcium. Over 42.28 grams of calcium oxide times 100 gives us 29.00 grams of oxygen. So you can use lab data, you can use a chemical formula to get part over total. So if we go back, remember this, percent is part over total. Part is what you're looking at, total is everything together. Sometimes you get mass of the part and mass of the total. Subtract to get the other part. Okay, so please be able to calculate percent composition. Make sure to dig chemistry. Alright, take us out, Fat Boy Slim. See you guys in 2015 for the next video notes. Notes. Alright. Hey Taylor, what you thinking about? Yeah? Did you say ever that many times? Mole? Don't believe it. Bye now.